Hey there, everybody. Welcome aboard. It's the weekly blog podcast for the Santa Barbara Astronomical Unit Telescope and Astrophysics Club that we call the SBAU Astro Hour. I'm your proud host, Ronnie Heron, and this will be our 267th YouTube program for April 6th through the 12th, 2026. We explore every week the depths of cosmology. That's Monday mornings, 11 a.m. from our individual homes, and our telescopes and astrophysics club meets twice a month out at the beautiful Santa Barbara Museum of Natural History. And our first Friday general meeting, next one will be Friday, May the 1st, featuring Dr. Abigail Freeman of JPL talking about Mars Curiosity rover. And then, of course, our second Saturday star parties outside at night featuring our telescopes, Palmer Observatory, and the public, just like our meetings, is invited. Find us online, please, at our website, sbau.org. And now for this week's topics. We're going to be doing a lot of comet commentary this weekend, or this particular week. So, you know, those European names they give the comets are getting weirder. This one, C/2024 E1, is Weirschos. That's what it's called. Meanwhile, Comet C/2026 A1 is plunging toward the sun. There's a whole family of what's known as sun grazers out there named Kreutz, Kreutz. And then there's old favorite Pan stars, or Comet C/2025 R3, glowing brighter than ever. As a great follow-up to Friday night's speech by UCLA's Dr. Malkin on his beloved Webb telescope in space, they're now focusing JWST on W51, a star-forming region. I guess that makes it a nebula. We'll find out. Finally, two very intriguing titles posted in our talking points with no narrative or details. One, solar video highlights of 2025, and two, black holes aren't black. That's asserted by Physics Today. So we're going to have to figure out what other color they're going to assign to black holes. Let's meet the crew. Commander in Chief, Mr. President, after 8 or 9, 10 years, becomes our professor of astrophysics, Jerry Wilson. Good morning, sir.
Good morning, everybody. Good morning to my sister Joyce and to my two grandkids, Calvin and Robot Tree.
And if
Yeah.
you, and if you family guys or any people at all, you'll leave a comment or a question on the bottom for Tim Crawford. I'll introduce Tim before I introduce you, Chuck. Mr. Crawford, how's Karen, your wife?
She's doing fine. She's going crazy in gardening.
And I got to tell you, looking at you on the screen, it's very bright in your house there. I can see.
Yeah, yeah.
Anyway, you're always there, I'm sure, on Star Party night, but you miss a lot of the meetings. We get Dr. Filipenko back in October. You'll be there at that meeting if we manage to pull that off.
Oh boy, only you could do that.
Well, it still ain't going to happen. Maybe Chuck McPartlin is our outreach coordinator, and he's awesome. Married to a lady named Pat, just like Jerry Wilson, the president is. Pat McPartlin is our merchandise manager and our incredible treasurer. We like to start every week, every particular program with some silly science cartoons that have been forwarded to us by our president. And we get about 7 if he revisits all of them. Some of them are thought provokers, which affect me just as good as a good laugh, because we need those thought provokers as little witticisms,
Hey,
Mark Twain allegories. So here we go. I'll let you guys. Okay, Mr. President, is this washed out to the rest of you?
Little bit.
It's
Okay.
fine though.
Well, we can sort of read it.
no, wait.
What are those angles? I believe that's the key to the whole thought there on the screen. Are you rebooting, Mr. President? I liked all of them.
I just need more coffee.
I'll get it, Jerry.
And a large syringe. Okay, Jerry, tell us about this. What is that? What do those arrows mean in the forest?
Well, this is a common problem I have between how to spell angle and angel. So, hey, put on a coat. It's like 20 degrees outside. Someone made snow angles. Did you just? This is such a cute idea.
Except there are two scientific things named degrees, aren't there?
Yes,
One
I
of them is
guess.
measurement, and the other is temperature. It's amazing. Got to be
Yeah.
something in common between the two, you'd think.
We had a thing like that happen at work. We made a system that it's like a radar system, and it has angles around the ship where you can designate areas,
Uh-huh.
and you enter a start angle and an end angle. And
Well, that's what.
we were writing up how to use the system, and we said when you want to set up one of these sectors, you put in the start angle in degrees and the end angle in degrees. And it was sent off to the government, and they had some people review it. And the review comment came back and said, "You failed to specify whether it was degrees Fahrenheit or centigrade."
Is centigrade and Kelvin the same?
Almost.
Yeah,
Almost, but not quite. I'll
close.
handle part of this one if you want. It's rather bizarro, these portrayals.
Yeah.
I got looks like an extraterrestrial is reading his daily Milky Way Times, and it has a headline you can barely read. Andromeda Galaxy player tests positive for asteroids. Apparently, he's got a social
That's true.
disease out there, a little
Those are
red dot.
nasty.
Who wants to take on the second one? Because I think it's a Wagnerian opera, isn't it? Wouldn't
Oh
that
yeah, the Aria,
be
the Aria 51.
Aria 51 is what happens when somebody sings the Ride of the Valkyries. It's just devastation everywhere on stage.
So they're doing an opera based on the Roswell event with the military showing up to collect the parts and the bodies.
I thought maybe it was just everything that happens out there in the desert of Nevada that we never know about. Crashes and
We really don't need to know about it.
I know, but that's what Area 51 is, you know.
No, that's Area 51 is actually in Nevada above Las Vegas.
Yeah, and you can get to the fence and they know you're there, don't they?
They will, yeah, they have patrols all around the perimeter.
Oh, well. Okay. Can you shorten it? Okay. Chuck, why don't you guide us through this one and make some sense out of it?
Okay, this is a comment on the comment section of every science post on Facebook. And it shows a guy saying, "Let me interrupt your expertise with my confidence."
Okay. Is that
Meaning, I don't know what the hell I'm talking about, but I'm absolutely convinced that I do.
Right. I'm not knowledgeable, but I'm highly opinionated.
Yes.
So I read it the other day in news that China has recently implemented new laws in their country that people have, if they comment on scientific truth, they have to have a degree in science by law. So the
really?
random person is not allowed to post their opinion online unless they can show that they're qualified to have an opinion on that topic.
Which still won't stop at all, but it'll help.
No, I thought it's a nice gesture, but it's futile.
Hi, Tom.
Hi, Tim.
Hi,
We have
Tom.
our former
Just got in.
Westmont science professor. You want to smile big, Whittemore? See what they just done to you in the dentist chair?
What did you say?
Are you okay? Hi, Tom.
I'm trying to understand what you said.
Somebody told me you were at the dentist this morning.
Yeah, just teeth cleaning.
Oh, I see. Oh,
Yeah, I
God,
told Jerry I might be late.
I hate that. All right, Tim Crawford, you want to tell us what this is all about?
I'll give it a whirl. Greeks invent trigonometry and prove that the earth is round. Also, Greeks, this is clearly a bear.
It's only the rear end of the bear.
Right.
You've shown me this so many times, Chuck, and I still don't get it because there's legs and feet and head and
Mhm.
Forget it. There's not.
Maybe they didn't have tippers back there in the old days. Okay, Tom Whittemore, you want to guide us through these four?
Sure.
Make some sense out of it?
Yeah, and God said, "Let there be light," and there was light. God saw the light was. Can you add support for dark mode?
In other words, it's too bright. Tone it down.
Oh,
Oh,
it's too bright.
yeah, I didn't get that one.
All that plasma that Mr. Crawford's trying to learn about.
Oh God.
Okay,
I struggled yesterday again.
Jerry, you're going to have to make sense of this one too. It seems to be redacted somewhat.
Yeah, the people that posted it have been lamed out.
Oh,
Honestly,
I see.
climate
Yeah.
change scares the heck out of me, and it makes me so sad to see what we're losing because of it. Maybe you should learn some actual science then and stop listening to the criminals pushing the global warming scam. I don't know, man. I already got a PhD in astrophysics. Seems like more than that would be overkill at this point.
Which pertains to your previous comment about having a degree before you comment.
Yes.
Well, you guys would probably know, was it Apollo 12 or 13 that read from the Bible as it was looking back at the
It
earth?
was
Oh, yeah, I
Apollo 8.
remember that.
It's from the Genesis. It's from Genesis.
It was
Yeah,
Apollo
right.
8.
And I believe one of the Artemis guys said something biblical the other day, and makes me wonder why they don't ever talk about astronomical discoveries on the pulpit from the church. They never.
That's a case of exporting ignorance.
Yeah.
Okay, I guess we're on a foreign planet, and this is their Disney World, or Disney Earth Mountain is one of their biggest attractions.
A
There's
big
something
throw.
I'm missing.
Space
Yeah.
Mountain. We have Space Mountain here, right?
Yeah, Space Mountain, and they're going to Earth Mountain.
This is actually more
Oh,
like
okay.
Matterhorn.
Yeah,
See,
that's
that one I got.
yeah.
Okay, this is more like the Matterhorn down in Anaheim. Okay, let's talk comets, guys. Unless we want to hit
Before we get to comets, I found
Nice
this
guy.
morning in space.com.
Aha, 11,000 new asteroids.
That's correct.
Hmm.
This faint blue band is the known asteroids before Vera Rubin went up.
Hmm.
And now Rubin has us discovered in these brighter bands 11,000 new asteroids. So it's going to be more like 100,000 new asteroids once they scan these other regions too.
Wow.
Very impressive. We're on the edge of a new age of data
Hmm.
gathering here.
Do they have to make a decision now to name some of them, and which ones do they name?
Well, they name them in order that they're found.
Yeah.
Well, not that many. They would run out of names.
No,
they're up
they
to
had to number them 1 to 11,000. Of course,
Okay,
they can
well,
put
that's not a
names on them.
name. Okay, numbers can be done, sure. Neil deGrasse
Why
Tyson.
are they in the shape of a spoke? Is that because of the aspect from where Vera Rubin's is
Yeah,
seen?
we're pointing.
I'm
Okay.
sure it's that, Tim. I'm sure it's that.
They looking away from the sun,
Yeah.
different angles. We see the
Taking
same
advantage
thing
of
when they
probably
map.
test images in other directions, and they just notice the asteroids in the foreground.
Yeah,
Oh.
basically Vera Rubin is looking for anything that changes from frame to frame, either brightness or position. So
And you can see there are some that are outside the orbit of Jupiter. They're probably Trojans. There's one on each. Yeah, there's a group there, and then there's like maybe 1 or 2 down here, assuming the color is not representing
yeah, right there and there.
something else. Yeah.
Wow.
But
Holy
this
cow.
is common in video, or not videos, but maps of the wider extent of the universe. You can see that there's an excluded region where we can't see past the center of our own galaxy. So, but outside of that, we see 2 big fan-shaped maps. Okay.
Before you go, my question about the Vera Rubin is, what is the biggest part of her being able to see these many? Is it the size of the mirror, or the fact that the rear of the camera has 1,000,000 pixels?
Yes, the latter.
Both together?
It's the size of the focal plane.
Yeah.
It's a very wide angle imager, but with a lot of light gathering power. So it sees a lot of really faint stuff. And I guess it takes, if I remember right, a whole sky picture every night. So
Well,
It can do I think it was the entire constellation of Orion in something like 21 seconds.
okay.
do like what? Just take a picture, or
Yeah.
Multiple pictures, but it can
Multiple shots.
scan.
Yeah.
Then the next day it does it again and they look for things that moved.
Yeah.
Right.
wow. I'm trying to get legendary Caltech guy Mike Brown to talk to us, and he told me last year in an email that he'd love to come, but he's going to be busy with Vera Rubin most of this year.
Yeah,
Oh,
that's
wow.
going to swamp him with data.
Well, maybe he'll want to come and tell us what he saw and bring some incredible pictures in the fall. That would be nice.
Okay, well, I'm glad you showed up, Tom, because you can
Yep.
tackle this Polish name.
Yeah, yeah. The name of that comet,
It's
Tom.
Birchus again.
Yeah, I would say Vishos.
Virshosh?
Yeah, the S on the end has an accent on it that turns it into an SH,
Okay.
like that. So I'd say Vishos.
Well, this is a picture from my old reliable, the Sky 6.
Mm-hmm.
And the coordinates for the comet tonight are right here
Okay.
in the constellation Orion, right near the bow that the hunter has.
So yeah, that's looking towards sundown.
Yeah.
Mm-hmm.
Yeah, this is looking west in the early evening at 8 o'clock.
And Jerry, do you know how bright it is right now?
It says 13th magnitude.
Oh, okay. Whoops. So yeah, a bright Pluto.
Yeah.
Yeah.
Magnitude 13, you can't see with the naked eye, can you?
Oh my
No,
gosh, no.
13th is the limiting magnitude under very good skies for a 6-inch telescope.
Yeah.
So a number I remember because my first telescope was a 6-inch telescope, and I would look at things trying to see 13th magnitude stuff, and it was tough.
Right. You didn't happen to have a criterion, did you?
No, I built one. It was very much, it would look like a criterion, but
Yeah.
I ordered the parts, the individual parts from Edmund Scientific, and then I put it together myself.
That's nice. So when I was a kid, I ordered the RV6.
Yeah,
Yeah. So it's an F8 6-inch.
yeah.
And they came out of Hartford, which is where my mom was born. And I just remember waiting for that thing to arrive in a big box.
Yeah, I was waiting for the metal tube to arrive from Edmund, same thing, Railroad
Mhm.
Express Agency, and I kept thinking, what the heck is that? They're delivering my part in a railroad?
Did you make your mirror too, Jerry?
No, I didn't. I bought the mirror from Edmund, 6-inch F8.
Okay.
I saved up that summer, and the entire telescope and the mount cost $105.
Yeah, mine was, I think, 200 for, the mountain and everything.
Yeah,
And I cut grass all summer.
ditto.
And guess whose grass I caught? I mowed. Kurt
Oh.
Vonnegut's uncle.
Oh.
Isn't that crazy? He lived up the street from us.
Kurt
The
Vonnegut.
uncle, not Kurt, but the uncle. Yeah.
Well, so it goes.
Yeah, that's a good one.
Wow.
Or hi ho.
Anyway,
Anywho,
yeah, what was the next thing I was going to say? Okay, this is a picture
Oh my gosh.
of Comet Virkos with NGC 300 in the background. This was not taken recently.
Hmm.
It was taken, well, it was. This is from February 2026, just
Okay.
last a month and a half ago. I tried to get a nice finder shot of MGC 300.
Yeah, don't know that one, Jerry.
But it's set at any time reasonable, so I didn't take a picture or didn't have a map of it.
Okay.
But you do have a nice picture of it coming up.
Yes, I do. It's a very nice galaxy.
After that really, really bad finder map.
Well, I see it's going to swing by the crab.
Yeah.
That's pretty cool. In 1807, I've shown people that at Westmont. It's a really nice open cluster.
In 1807? Oh,
You see 1807? Yeah. That's kind of up near the Hyades.
Yeah.
It's in the ballpark of the Hyades.
Okay.
are any of these three comets we're talking about, because I've lost track here, the interstellar one?
No.
Oh, okay. We're not doing, is that gone? Can we not see that anymore?
Not amateur.
Oh, I see. Okay.
Jerry, now that I see the word, okay, I'll go. So it's ours is pronounced as je, virch, hosh. Virchow.
There's
That's how I would say that.
Virskosh.
Yep.
surprised that's not the name of a European car you can buy.
Hmm.
Got a brand new Virchkos.
Yeah,
It works.
that's a real nice Polish tongue twister. Yeah, 1647, by the way, up there. I've shown that at Westmont. There's
Uh-huh.
some really nice open clusters up near the Hyades in Taurus.
Plus the Hyades.
Yeah, plus them. Those are binocular gigs.
Yeah.
Yeah, they're nice and binoculars.
This one's really burned out in the middle.
Gosh,
Okay.
boy,
That's
is
too
that
bad. It's
beautiful.
really good.
That is just gorgeous. Is that a Hubble?
Uh-oh, my software is frozen up here. Can you hear me?
Oh, yeah.
Yeah.
Mhm.
Okay.
It's an ESO image, so
Okay.
Well, I missed it. What are we looking at? W51? No.
no, this is NGC 300, that
Yeah,
galaxy.
300.
Oh, yeah.
I didn't know that one.
Hmm.
Okay.
But this telescope is picking up, if you look towards the very right upper section, some pretty darn distant galaxies. There's some sort of a needle or something way the heck out there.
Right on the edge.
Yeah. Hmm.
Huh. But the other bright balls, are those stars or galaxies? The other balls. that are
Okay,
around.
I'm going to have to get out of Zoom and get back in.
Okay.
Oh, God.
Okay.
So anyway, yeah, I'll be right back.
It's happening in the captain's cockpit there. That's
Yeah.
the rest of us are on our own, drifting in space.
Yeah, this is a heck of a shot. I mean, you can see the H2 regions in that galaxy glowing kind of towards the purple red. Really pretty.
Does it have a name or a number?
NGC 300.
It's number 300. Yeah, NGC 300.
So we haven't named it yet, then we don't like
Yeah.
sombrero or pinwheel or
No, I mean, it looks like a pinwheel face on to me. It's really
yeah,
pretty.
it's definitely a spiral.
Yeah, it's Southern Hemisphere, I suspect here,
Oh, oh, really? Okay.
because or very low for us, because the comet picture was taken by a fellow who looks like he might be South American,
Okay.
and then this is an ESO image, so from Chile.
Okay.
How many hilltop planetary or observatories are down there in northern Chile? Do you know? Does anybody know? They keep
Dozens at least.
Dozens of Mount Parnal.
and the country, the long skinny country that borders the west coast of South America is making a fortune. That's probably a big part of their gross national product, just money from our
Yeah,
astronomy
but you can
department.
see, Ron, the light is creeping up and on
Yeah.
the horizon. It's
They-
creeping up.
They did manage to block that development that was going to be down in the Atacama that was going to brighten up the skies.
I see.
I don't understand. Is that the mirrors in the sky?
No, there was a development that was going to be some kind of mining plus power generation from, I think, geophysical heat sources in the Atacama Desert that was going to brighten up the skies for some of those observatories.
Wow.
You suppose they were going to be digging for rare earths? That's pretty hot stuff these
Mm.
days.
Might have been for because of
Lithium?
that desert stuff. It might have been for lithium. Yeah.
Hmm.
Yeah, I heard lithium is just across the sands of some places and deserts around the world. In fact, down there. And that's the basis of the new hot batteries that catch fire on airplanes.
Yeah.
There was a
Suppose we don't get the
discussion
pres-
There was a discussion on TV this I think this morning about the Artemis voyage here, where there's a company that an ex astronaut started, and they're going to try to mine. It's a mining company, and they're going after helium-3 on the moon.
Hmm.
Helium-3?
Yeah, very rare.
Helium-3, and it goes for something like, I think he said it was like $3 million. No, $9 million a pound
Yeah.
for this stuff.
So,
A pound is a lot.
It's
oh
not a gas?
gosh, yeah. So, Ron, the usual helium is 4, right? 2 protons, 2 neutrons. but helium-3 is much, much, much more rare. And we built these helium-3 4 refrigerators for the research I was doing with Dr. Stark. And Stark brought back from the University of Chicago a little bottle of that stuff. So it was because it was so expensive, and we recycled it. So you recycle it in the refrigerator. So basically, you use helium-3 against helium-4. Helium-3 is lighter. So it kind of in a refrigerator looks like it's evaporating off the top of 4. And that's how you get the cooling. So it's basically an evaporative cooler. Okay.
Mm.
And
So
we,
I think it fuses easier for fusion reactors.
yeah. Okay.
but it's still a gas,
Yes.
Yes.
and it has one neutron, not two.
Yes. That's
And
right. That's why it's 3, helium-3. Yeah.
is
2
it,
defines the element. So element 2, helium.
but
Okay.
could we fill a balloon with it, or still sound like Mickey
It'd be
Mouse?
a very expensive balloon.
Yeah.
Oh,
Boy.
it's rare
No, we
though.
used to save that stuff and recycle it. It was so darn expensive. Um,
Save helium-3.
helium-3, yeah.
How would you get it?
That one,
Doctor,
that one is, he didn't really discuss that because I
yeah.
thought it was a solid and not a gas.
Oh no, it's
Yes.
gas.
Yes.
And
So we used to cycle it. We built these refrigerators, and when you say refrigerators, I'm not talking about a Frigidaire. Okay, I'm talking about taking things down to 20 millikelvin. So 0.020 kelvins. So we used to, because we wanted to have our data very much free of noise. We used helium-3 against helium-4. That was the last stage of the refrigeration. It went through several stages, but that was it.
well, this guy was mentioning that the helium-3 is going to be a very rare element that we
Oh
need,
yes. Oh yeah. Mhm.
that you need for, I think it talked about fusion reactors, like you
Yeah.
mentioned.
Yeah.
And that's going to be interesting because I thought fusion. Remember, we had a guest at Farron a few years back, and he
Hmm.
says, "Oh, we're just a couple of years from fusion." He says it's not pure fusion, but it's like fusion.
Yeah.
And he said once we get there, it's going to change the market completely. And
Yeah.
I don't know if I go along with that.
Yeah. Just as an add-on, how would you ever measure how would you measure a temperature of 0.020 kelvins?
Yeah.
What you do is you measure the resistive properties of carbon. So that's what you do. And then you convert that to a temperature. It's really exotic stuff that, we did our work in. But yeah, I'm basically a low temperature physicist, even though I love astronomy.
Well, they were talking about the extraction process, not in terms of how, what they were going to, how they were going to do it, but how the vehicles they were going to get
Mm,
it back to Earth, and
I see.
that's going to be a trick.
Yeah. Yeah.
So this supposedly this rocket that they're testing right now, it kind of boiled down to a really just
Yeah.
basic ideas. They're testing the module to see that it can support life to the moon, and
Yeah.
that's it. It's just a basic thing they're trying to test
Yeah.
because they're planning on going there and staying there.
Yeah.
So if they have the vehicle to do it, this could be it.
Yeah. If I might change the subject just a second here, it's just
Yes,
yesterday,
Jerry.
of course, Tim knows we got 88 people at the solar event.
You're
And
breaking up.
I think Jerry's calling
You got it.
our outreach. He can't check in.
Yeah.
Yeah, Jerry wants me to send him the link to the meeting. So here we go.
okay. So while Chuck is doing that, I just want to honor David Larson because he's been doing an amazing lot of stuff on his own. And yesterday I saw him taking little plates out of a box, and then putting them on the electronic fixtures in the observatory.
Yeah.
They were crafted so they would fit. Now he's just done some amazing stuff, and much of the reason that observatory is working like a champ is David. It's David Larson. He's really good.
Yeah, he really took that and ran with it.
Oh yeah, no, he
And
is good, Chuck.
and what he was worried about was a bunch of switches, apparently. If you had a little toddler in there visiting the
Yeah.
planetarium, visiting the observatory, it'd be easy for them to throw a bunch of switches accidentally.
Yeah.
And
Yeah.
so he's protecting them.
Yeah.
Yesterday he showed me a box. He showed me this plate it's clear
That's
plate.
it, Tim. That's it. Yeah. And you could see where he machined it at home so it would fit properly.
Yeah.
Okay. Onto just electrical outlet fixtures, right?
And
Yeah.
also on the motors, I think, so that you can see the gears turning when it's
You can
Oh,
see the
yes.
gears turning. That's the one that he showed me. And you
Yeah.
could literally see the thing tracking and it was, the gears were going slow, but you could see it.
Yeah. You could see the ratio, the turning ratio from the little sprocket to the big sprocket.
And
And
that's going to be neat. That's going to be neat
oh
for
yeah,
customers.
you can just say to somebody like David said yesterday, we are tracking. Look.
Yeah, yeah, yeah. There's going to be a lot of days where we're gonna have fog, and there's a
Yeah.
lot of days that happens.
It,
Uh,
you know, surprising, Tim, yesterday, I think you saw my friends come in. We had just had breakfast with them,
yeah.
and they just popped in. They were just basically a walk away. And Jerry was there, and it turned out Jerry worked with my friend Steve Hodges. So they saw one another for probably the first time, I don't know, 20 years, something like that.
Huh.
Um, and it was really neat yesterday. It was really neat to see that they walked over and to enjoy the sun.
We get customers now. I mentioned this, I think, to Jerry, or was it you, Tom, that I
Mhm.
said we're getting customers from all over the world.
Oh yes, yep.
And we had a couple of customers yesterday, and they're always translating. We might say something to them, and you're constantly translating.
Yes, Jerry.
Well, what's
Jerry?
the status of the surface of the sun nowadays, as of yesterday, gentlemen?
Yesterday there were some pretty good prominences, Ron.
Yes, Jerry.
You don't see
And
sunspots?
there's some brand new sunspots
That's
coming
what I
up.
used. Did you
Oh,
accidentally grab the carriage return at the end or something?
what I want to know is what happened to the cats
Okay.
that walk across the screen? I haven't seen
Yeah.
them. We lost our leader.
So Ron, you should come by sometime on Sunday. It's really neat. 1 to 3.
Well,
Tim and I are always there.
I
And,
will do that. I promise you.
yeah, it's really nice. I think you'll get a kick out of
I
how
will
that
tell.
place has been spruced up.
I will tell this to you, gentlemen. You probably aren't even aware of it, but I went a couple of times
Uh-huh.
out to Westmont
Yeah.
and sat on a chair at the base of the stairs that sweep around the edge going up to the upper level of the observatory
Uh-huh.
and watched everybody come and go and line up, and nobody ever knew I was there. I finally let
Yeah,
them
I didn't
know.
know that you were there.
I
I
see.
did that a couple of times and decided, unless I'm greeting people, what am I here for?
Yeah.
I
Well,
can't.
pretty soon it's going to get weird out there again because of the World Cup, and they're going to do the same fencing that they did last year, where they fenced it. Where they brought a local fencing company in, and they put miles of fencing around
Yeah.
the soccer stadium and around it. It actually kind of goes around the observatory as well,
Hmm.
and keeps one of the parking lot. Oh, the baseball stadium that's
Right.
locked out. So when you go up there when they do this, you're literally you're kind of driving up a tunnel of fencing with
Yeah.
windscreens all around you. So it really is weird. You're looking at a little prison in your car.
And Jen was saying that they might not let us have our observations.
Oh yeah, it
Look
might not
who's
happen.
look
Yeah.
who's back. I think
Hey, there's Jerry.
Yeah, I
those
missed
cats
a
are
few of the
aggressive.
last ones because of music events.
Yeah,
Yeah.
we might have rain Saturday, by the way.
Yeah.
Wow.
Friday
Yeah,
at least, there's chance of thunderstorms, and then Saturday some lingering stuff.
Wow. Yeah, this morning it smelled like moisture, you know.
Yep.
We took the dog out for a walk.
It's going to be it's going to be touch and go. It works for me because there's so many events this month that I'm trying to stay steady Eddie on how many I do. I'm not
Right.
like
Yeah.
Chuck,
Yeah, Astro Day is coming up. That's always
Yep.
fun. Yeah.
Hmm.
well, Mr. President, did you write down that sign-in password or whatever Chuck
I
gave
did
you?
again. I had the sheet that Chuck sent me earlier with all the sign-ins on it, and it was a JPEG. I saved it, and so I didn't remember that. I thought I saved it in Word, so I couldn't copy the number.
Couldn't
Oh,
select
yeah.
it. Yeah.
Yeah.
So anyway, I will
Here's
post
NGC
that for-
300.
It's just
So anyway, back to our meeting. This
We're
is
halfway through.
this is NGC 300.
yeah.
Very nice. This is a 50-hour exposure
Wow.
with the European Southern Observatory at La Silla Observatory in Chile.
Mhm.
One of the big telescopes, 8-meter mirror. So this is really getting into, you can see a lot of star forming regions like our Orion Nebula in here. These red things are hydrogen. You can see the core in galaxies. The core is usually yellowish to green, which this is here, and then bluer out here. So
I suppose it's about the same size as the Milky Way.
about,
No?
yes,
Oh, it is. Oh,
yeah.
so about 100,000 light years across.
Wow.
I wonder how many light years
So
away.
this is just the background for Wirtstrasse.
Oh,
Mhm.
I see. Got it. Is that in the picture? The comet?
Not this
Was
one.
in the earlier picture, Ron, that showed it.
There it is right there.
Oh, I see. Got it.
So it's past it. It could be going this way, but I don't know. But it was in the region where it was a nice double catch for this guy.
Two tails.
Wirtschos.
Yeah.
Now,
We're easily
this-
amused.
This is another comet, 2026 A1 MAPS, MAPS. That's an acronym that stands for something.
And it disintegrated.
Who did it?
Yep.
Okay. So they
Really?
gave a rather hopeful view of it. Yes, it went around the sun. Its apogee was
Saturday, I think.
Saturday, the 2nd of April. Yeah.
Sorry,
So anyway, it was coming in well inside Mercury, and it was going to go within 100,000 miles of the surface of the sun.
Wow.
Okay.
So
Now,
most comets, and apparently this one too, do not survive that. This was the photometry for that comet
Mhm.
as it came in.
I didn't get this.
What's that?
I didn't get this this graph.
that's how bright it is with a prediction of how bright it was going to get.
Yeah.
Oh, okay.
And here, this is April 1st. This is April 2nd when it was closest, and apparently now part of the sun.
Yeah, it disintegrated.
Yeah.
so that's what we're looking at is the residue, all those specks and dots and
No, those are brightness measurements as it was coming in.
Yeah. This is on March 1st. This is how bright it was. And this is how bright it was on March 15.
Mhm.
And this was how bright it was on April 1st. And this is how bright it was projected to be on April 2nd.
Wow. And Space Weather just had a movie of this,
Yeah.
and
Yeah.
as it got closer to the sun, all of a sudden it got really, there was a real big flare, and I think that was it flaring out.
Uh-huh.
And this is a graph of that comet as it was coming in and was going to go out.
Mm-hmm.
And this
It's
is
supposed
the
to be
view
pretty
of
bright.
it. Well, when it was near the
Yeah.
sun, it was pretty
Yeah,
bright.
I mean, I saw it was predicted to be -2.
Yeah.
Yeah, that was daytime visible. Yeah.
Yeah,
Yeah.
see the spike there, Tim? That's
Yeah.
-2 or so.
Yeah.
Yeah, they were saying it was going to be daytime visible, I think.
Uh-huh. Except too close to the sun.
Yeah.
Yeah, yeah, yeah.
Minor problem.
but
So
is
this would have been the path it had in our sky.
Oh, wow.
Going back out.
Yeah. And this is a picture from April 2nd from the what is that? SOHO satellite. That when it gets within a certain distance of the sun, it's in the same field of view. And here it is heading for the sun on the 2nd. And it's going very fast. And this is probably, well, it was probably in this disk when it died.
Yeah, it was.
Yeah.
And then you
Okay,
saw
I
a
have to
splash out
see.
the other side, almost like this mass ejection that it's showing.
Yeah. Yeah.
Well, depending on the timing, gentlemen, that seems like something you might be able to see on your Sunday sessions at the observatory on
No,
Sunday at the
no,
museum.
no.
It's
Can't see
bright,
it?
but not that bright.
Oh, it's okay. So it's not like a prominence or anything like that.
No.
Got it.
Okay, now we've got to shift over because that software thought it was the last
Our
slide.
little hydrogen alpha scopes, we had just a little bit of misty clouds out, and they're really affected by the
Yeah.
the sky and the scene. Whereas the white light that Tom runs, that's still going.
Yeah.
Uh-huh. Okay. So anyway, that's where we were. Now this is, I'm sure this is washed out.
No, it's pretty good.
No, no, that's good.
Looks
Okay.
good, Jerry.
Okay. So this is the family of the Kreutz, Kreutz
Right.
family tree for this comet.
Yeah, German for cross, Kreutz.
Yeah. So anyway, these are believed from chemistry, not chemistry, from spectroscopy. They can say that these things are related. They are pieces of a very large comet that came close to the sun. And the sun, with its tidal forces, broke it apart into major superfragment 1, superfragment 2, and these broke up into, and this is the family tree for what we see. Well, I don't see the name of our comet here, but this is a family tree for a Kreutz comet. It's a family of comets, and this is the family, and they all came from one progenitor.
Oh, is it maybe on the left tree, the 1A right there below superfragment 1 to the left? Right there.
No.
Oh, that's not it. Okay.
Well, that broke up into the Great Comet of 1880 and 1887. This one, the most recent one, was 1945. Fragment 2D.
There's a 1970 there, K1.
Yeah.
You did use the term sun grazers.
Yeah.
And these are the dates when that they were observed: 1847, 1700,
Well,
1749.
when they might have broken up, I think.
Yeah, when their estimated breakup was.
So in effect, when something gets destroyed by going on a comet, goes that close to the sun, suddenly it's still in its path, but millions of little comets, right? Debris.
Yeah, a lot more, if they even survive. There was a comet a few years ago, about maybe as much as 10 years ago or so, that went around the sun, and then it was a very close to the sun comet, and then it was observed again after its perihelion, and the comet was slowing down visibly as it was moving away from the sun, but not as much as gravity would have slowed it down. And the reason it was slowed down was the core, the nucleus, had completely evaporated, and what you were just getting was the tail still continuing on.
Really?
So they backdate these by looking at the at history, at the data that they've collected, and backtrace them to how they must have fragmented.
They look at the orbital elements. Yeah.
Okay.
It's a undergraduate problem in celestial mechanics. You can, from any 3 observations of an object, you can compute its conic section orbit from it. And that's an exercise to do that.
Wow.
The surprising thing about it is that these numbers are very big numbers, not in terms of the size of the number, but in terms of the number of decimal places it has in order for it to be accurate. So it's highly measurement dependent. And then as the comet goes around, in your homework problem, it's an ideal thing where it doesn't change orbit. But a real comet, when it sheds the stuff, it boils off volatiles. Those are like little rocket engines that cause it to move around and change its orbits.
Oh, no kidding. I didn't know that.
Now, this is a famous comet that didn't make it either, In 2011, this is Comet Lovejoy, and it's headed right for Mama there.
Oh, what a way to go. Does anybody know what the Parker probe is doing these days?
It's orbiting the sun.
I know, but is it sending us back pictures or monitoring these comets?
It's looping in and out, and it's on a slow outward part of its orbit right now, I
Oh,
think.
that's true. They do that, don't they?
Yeah.
Yeah, are we going to lose it someday to the sun?
This one, the Pan stars.
No, the Parker.
Oh, I think we will.
Okay.
Every time it comes in for a close approach, it's the closest we've ever been to the sun. That's the headlines.
Yeah.
One of these days, it just won't send out a signal.
You know, I think they did have a predicted date on that.
They have a predicted date on everything on that. You can look it up.
Well, I imagine it takes a lot of damage, even with that extensive heat shield. It can't be good coming
At some point, the heat shield will fail.
Oh, dear.
It can't prevent heat, it just slows it down.
But it's not looking at the sun, I would think.
Yes, it is.
It is?
Yes.
You can filter them down that much when it's
Yes.
that close. Wow.
You know, no, I won't mention this. This is the comet Pan-STARRS. It's another comet in our sky. And right now, this is, let's see, I believe this is east.
Early morning, yeah.
Oh yeah, early morning, 5 in the morning, and the sky probably is, and this brightness down here is the Andromeda Galaxy coming up. But this is where Pan-STARRS is right now. And if you're good, you can get this in the morning and you avoid the sun. Probably another, I don't know what time sunrise is around this. It's probably around 6. No, I got up at 6 a couple days ago. That was bright.
Yeah, it's quite bright by 6.
Yeah. Okay.
Or
Anyway, this
commentary.
is a very nice picture of Pan-STARRS.
Wow.
Wow,
And I think
that's a great picture.
this is taken by a refractor. And
What's the green again around the head?
That's a chemical that's an unstable chemical that is created by the comet head. And if the comet's traveling at a normal speed, the stuff decays before it gets to be part of the tail. If the comet's moving very fast, you can get some of the green back into the tail, but I forget the chemical.
Diatomic carbon.
Okay, thank you. So this one, you can see the pattern of the diffraction spikes around the star here. They're the same for each one. They're not a simple cross. They have 2 wedge-shaped chunks out of each side. And this is caused by, I made a wide field camera out of a World War II surplus aerial camera lens. And it had a very slight bubble in it in one of the elements. And the bubble produced this kind of pattern. It had a missing, you could tell from the angle where the bubble was located. So it could be a defect in the lens, but more likely, this is somehow related to obscuration from a central support in the refractor for a wide field camera. You can learn a lot by looking at the images.
Well, can you give me an idea of the time, the distance here? How long would that tail be in parsecs, or I guess
It's not parsecs.
not parsecs, not inside the Milky Way, but is it dozens of light years or no light year? Or
No.
Oh, no,
It's going to
no,
be
no.
hundreds of thousands of miles, but that's about it.
You're right about diatomic carbon, it says here. And let's see, its interaction with the solar wind. The comet is currently glows at 7th magnitude, and it's visible just before the start of dawn, low in the eastern sky. So it's going to be a challenge to see. But the tail is, I don't know, not an astronomical unit long, probably.
Really? Not even that long.
Much shorter than that.
if we were to pass through it at night, we'd get an incredible meteor shower.
Yep, we'll get a meteor shower if we pass through it.
But over time, those tails that become the focal point, what's the word for radiant, I guess?
Yeah,
They
it'll appear to
disappear.
come from a
You
place in the
can't see
sky.
them until they just become little specks of light falling to Earth. They're gone, right? A lot of it is water molecules.
The entire orbit will be decorated with this tail, this expanding tail and the particles that are in it.
Huh.
So if it's in the plane of the ecliptic, we'll probably see it quite often every year. Or if it passed through, we'll see it probably less often.
Do any of you gentlemen know the next radiant we're going to cross, the next meteor shower? What?
Yeah, I think it's coming up in a week or two, but I've forgotten the name of it.
Lyrids?
Lyrids, yeah.
Yeah.
Something like that. It'll be in next week's talk. But we have to be within a week of it for me to put it in here.
It's just Mother Nature likes to provide us with entertainment on a constant. It's just great.
Okay, now, as you mentioned earlier, we had a wonderful talk on last Friday evening from a fellow at UCLA that got first dibs on the JWST. And I see why he did it. He shotguns applications to the committee that decides who gets to use the JWST. And he got, I think he had quite a number of things submitted, and he got 4 of them approved. And so he got one of the first views through it, and he showed a lot of pictures. These are not one of them, but these are similar. This was shown, I believe this was on a site for space.com, and it shows the typical diffraction pattern for the James Webb with these 6 diffraction spikes. So these come from a single star that is in this nebula. This is a starbirth region, and it's taken in the far infrared, and that's how you can see through the dust. The longer wavelength light is not scattered so much by the particles. It's also why the sky is blue but not in the infrared. It's because of Rayleigh scattering. And the shorter wavelengths are scattered more.
But Jerry,
Yeah.
the 6 spikes are because of the 6-sided pieces, the honeycomb of the golden mirror panels. Is
Yes,
that why there's 6 spikes?
yes.
So, if so, why do you get 4 on your scopes?
Because I have 4 veins on my spider, the thing that holds the secondary in place.
And science could explain it to somebody even like me, or
I don't know about that, but they're very easily explained.
I don't understand. I wish I understood. Why is there a spike? What is
It's
If you have-
diffraction of light, but also the Webb has three struts that go out and hold the secondary mirror, and that contributes to it too.
Yeah, that would give you 6 spikes also. My first telescope, the 6-inch f8 that I built, had a single metal rod that stuck out from the eyepiece or from the focuser, and it held a secondary elliptical mirror in the center, which looked at the tilt angle, it looked circular. But that one single spike or one single holder line support produced a spike, a diffraction spike on each end. So I always had 2 diffraction spikes around it. So if I have 4 veins holding it up now on telescopes I make now. And so you always get 4 spikes. There is a technique that people use. They don't like the spikes because they make the supports for the secondary, they make the supports to be circular loops. And then there's no spikes that showed up. It smears the diffraction pattern out evenly over the whole field of view. But you get a higher resolution if you're a visual observer of planetary details. You will want these 4 spikes that you have, and then you'll rotate the telescope tube so that the planet you're looking at is between, does not correspond to one of the spikes. So all the diffraction error is concentrated in here, and you're looking past that into a clear part of the field of view.
That's interesting.
If you have a circular support system, then it's smeared over the whole thing, and you lose a teensy bit of contrast everywhere in the field of view. If you have these spikes, then you don't lose any contrast between the spikes. It's all concentrated in the spikes.
But I don't seem to recall seeing these spikes, either the 4s or the 6s, in your telescope lens. We're talking about pictures?
Yeah,
Film,
well, these spikes are faint, and you have to take a long exposure to make them show up. You do see them on, if you look with my 12-inch, I've seen them on Sirius.
Yeah, on bright stars you see it, and it's actually, I don't know, kind of pleasant.
Yeah, I like it. And as a matter of fact, in that vein, there was a person who I know uses a refractor which shows no spikes, and yet his pictures show 4 spikes. And I said, "What's going on here? I thought you use a refractor." And he said, "I string a monofilament line across the front of my tube, so I always get those spikes because I like the spikes."
Oh,
So there are
And yet-
people that don't like the spikes. There are people that like the spikes. Whatever
and yet,
suits you.
and yet the common long-time historical picture or a diagram of a star is 5.
That has nothing to do with reality. That's
I know,
just
I just-
artist.
That's how you draw a star. It's
Yeah,
part and parcel of witchcraft and occult, and Lord help us. All
you know,
right.
and I know this is, I'm going to probably regret saying this, but the batten off masks don't relate to this, do they?
Yes.
yeah, they do.
Okay.
It's playing with diffraction spikes. So you can there's a couple ways that I focus my telescope. If I'm using a DSLR camera, they let you look at live view, and then you can magnify the field of view 10 times. And that's sufficient for me to visually look at the image while I focus it, and you can get a really sharp focus that way. But using a batten-off mask on a big telescope with other kinds of cameras, it makes a diffraction pattern, and it actually makes 2 diffraction patterns. And when the object is exactly in focus, the one diffraction pattern goes right down the center of the other one. And that gives you an extremely precise focus.
Yeah, they're really they're a neat item.
Yeah.
Yeah.
See, down here, there's a
8.
set of, there's 8, and there's these little ones right there. And this is what a batten-off mask looks like, makes the star look like when it's
In focus.
when it's when it's in focus. Yeah.
Okay.
When
Okay.
it's out of focus, these center little ones will be up here somewhere or down here somewhere. And
Oh, interesting. Okay.
and
All
you
right.
move the focus back and forth until the pattern looks just like this, and then you're in focus.
Yeah, I have one for my 4-inch, and I've yet to use it, but I've seen Chuck do it. It's interesting.
And they make them where, the first ones that came out were solid with the holes cut in them to
Yeah.
cause fraction spikes. And I had one of those, but then I got one that was made out of plexiglass, so it's transparent. And it's much brighter and easier to see the spikes because you're not blocking a lot of the light that comes in
Yeah.
your aperture.
Oh, okay. Be interesting to actually make one. I don't think it would take much to make one.
No, you just have to be precise.
Yeah.
You have to calculate it for your aperture too.
Oh.
Well, I
And
didn't have a
there's-
chance to ask Dr. Malkin Friday night. I concentrated on my stupid question instead. Where do they monitor stuff from the web? Is it at JPL?
Yeah, they would,
I don't know
the
what
Deep
I don't know
Space
what you're
Network.
asking.
What, Jerry?
I don't know what you're asking.
It's the Deep Space Network, Ronnie. They send the signals to that, and that's run by JPL.
So it's all in Pasadena.
No,
One download place.
no. No,
Oh,
because the Earth is rotating, Ron. So it's all around the world. It's the Deep Space Network, and they have the receivers around the world, and then they send the data wherever, wherever they want to send it.
there's not a central location where they're always looking through the, I guess, eyes of
They
the
got
web.
us. They have antennas, as Chuck points out, antennas all around the Earth, and they all send their data to a central location where it's collated and stored, and that's in JPL.
Okay.
Do we have time for a little interesting story if we're going to end that right now?
No, we're not going to end right now.
Oh, okay. And then I'm going to refrain.
Well, no, why? If you want extra time, go ahead.
Yeah, I had a buddy that lived right next to JPL at a very early time when JPL was just forming. He used to ride a horse to his school. And he and a buddy were riding their horses home, and they were riding down, and they found these tunnels that were around where JPL was near the creeks and stuff. And so they just got off their horses and they wandered into the tunnel and were met by people saying, "You can't be here." It reminded me of that Area 51 story that you had.
Yeah, JPL was an Area 51 of its day.
Yeah, and it was just a tunnel, unmarked, but they just wandered in and they were met with a pretty forceful, get out of here.
Uh-huh.
Well, they were testing things like rocket engines, so yeah.
They
Yeah,
were, they were testing the F1 engines for the Saturn V out in the Santa Susana Pass area.
Wow.
And I lived up the side of the Angeles National Forest, on the opposite end of the San Fernando Valley. And we could hear those rockets being fired, and we could see the glow on the Santa Susana Pass as they were firing it off. When we were in high school, and we were always wondering, what was that? What's going on? Is it some secret thing? And it was.
Well, Caltech is right next door. Which came first, do you suppose, JPL or the university?
Oh, JPL is part of Caltech. They're the same.
They're
Yeah.
the
They
same.
share
Yeah.
parts of the campus. But JPL is a national laboratory, like
Like Livermore.
yeah, like Livermore.
The stories I heard is that when JPL started, they were Caltech students went down into a creek bed and they were firing off little rockets.
Yeah.
Yeah.
And that's how it all started.
But do you suppose it's just riddled with little offices that are monitoring different things? One is for curiosity, the other is for perseverance, the other is for this space telescope, and the other is the web. And there's just everywhere you've got something being monitored at JPL.
They got a ton of buildings there.
They will have teams that a team specializes in something like that. Just like where I worked, we handled multiple contracts at the same time. One would be working on the sensors for the JWST, and another one would be working on sensors for weather satellite. And we had a meeting.
Is Artemis now under the control of Houston?
I don't know about that. I think so.
Yeah, JPL has never been involved with Apollo and the manned missions, has it?
Oh yeah, they're involved.
But as far as controlling and talking to them and running everything, I mean,
That's Houston.
that's
Yeah.
Houston. It's almost a joke. Yeah, hello, Houston, we have a problem.
Yeah.
Well, we don't have a problem except for what Zoom does to us. Hey, guys, let's do it again.
Well, wait a
Next
minute.
week.
We're not done. We're not done.
Oh, I'm sorry. I thought we were.
Okay. So this is a picture of this is in near infrared. So we see that star is completely gone. The wavelength here that we're looking at is too short to see through the dust. So we're looking at the dust in this case. Now, I want to show, see if I can do this.
The big chart.
What's that?
The big chart. I like that chart.
Oh, we might get that to that. It depends on.
You posted two just statements on the end of your talking points, Jerry. Solar video highlights and black holes ain't black.
Yeah.
we're not going to get to talk
I'm
today.
going for the solar highlights of 2025 right now.
You know, we have a member, John Boyd, who's done a video of this solar cycle too.
Solar cycle.
Does he have, Boyd has that?
Yeah.
Oh, wow.
I don't understand. What is that? What does that mean? The 22 years?
No, just this cycle, this bit that's happening now, the peak.
Well, I heard there was an 11-year cycle. I guess there's others.
It's 22, but it looks like 11 from here.
Oh, I see.
Oh,
Okay.
there's a good one.
Yeah, these things, the reason that this catches my eyes is that you can see the structure in real time of the prominence. The prominence is a magnetic field that you cannot see real well, but the material up here is not being brought up and then dumped down. It's being cooled off in the atmosphere of the sun and then falling down. So, and then this whole structure, as the magnetic field rises, that whole structure can rise up slowly if it's a prominence and very rapidly if it's a flare. But it's the magnetic field that does the lifting.
Oh, that's neat.
You said it cooled off in the atmosphere of the sun. I heard that that's one of the hottest parts of the sun. The
It
corona.
is. It is. And when heat is disorder, and when you add order to heat, it sets in effect cooling it off. And so the magnetic field up in that hot area, it aligns the individual velocities and makes them less chaotic. And that's in effect taking some of the heat away, because heat is disorder. When you add order to it, it cools it. It's a method that's used. Adiabatic demagnetization is a technique that's used to get the very lowest temperatures you can get down to millikelvin, but close to absolute zero. You align everything with a magnetic field, and then you put a barrier around it that's adiabatic. It can't allow heat to get in, and you turn the magnetic field off, and then everything is aligned at a very, very low temperature. But these are very dramatic pictures taken by an amateur. Yeah, I assume it's in Arizona because his name down here is AZ Astro Guy.
Mm-hmm.
And this is revision to my best of 2025 solar video summary. All images and time-lapse videos are real and captured by me, meaning him. There's also music to it, but I didn't want to risk trying to get the music in it too.
But is this the sort of stuff you guys see on Sundays at the museum?
This is higher resolution than we see, but yeah.
You actually can see prominences, flares.
Yeah.
No, but we don't see him move though.
Oh, you see them move a little.
Yeah,
A
we
little
see,
bit?
yeah, you look back an hour later and you can see it's changed shape.
Oh,
Yeah.
yeah.
Wow.
But I think these videos I think are time lapsed, aren't they?
Yes.
Yeah.
Yeah. You took a
That's-
picture every 15 minutes or something.
Are they ever recorded or video saved somehow?
Yes, sure.
Here they are. That's what you're looking at.
Yeah.
Well, I'm
And I
talking
think
about
this is what John Boyd did.
Yeah.
Oh, really? Fantastic.
What John Boyd does is he goes out and collects the Soho images or from one of the satellites, and then he
Uh-huh.
takes them and patches them together to make GIFs. And he's made one of the so far this high point in the cycle.
His last name is B-O-Y or V-O-Y?
BOYD,
BOYD.
John
Yeah.
Boyd.
Boy. Well, okay. Despite losing you, we did all right this hour, gentlemen. Thank you
But
very
wait,
much. We're still doing it. Well, hell, let's make
we're going to
it
give a
2 hours.
preview of next week.
Oh,
This is cool, Ronnie.
we never get those. All right, what are we going to be talking about? Cats,
A
planes?
single video of a really nice graphic that explains black holes. Black holes aren't really black. This is talking about who's that guy? Hawking radiation
Oh,
and
Hawking.
why they will decay. And it discusses the physics in a very simple graphic way. This is an article from Physics Today magazine published by the American Physical Society that I'm a member of and subscribe to. And so we will go step by step through this next week.
Ooh. Like one big cartoon at the beginning.
Yeah.
That's probably why I like it.
I think we might be able to understand it, Tim, you and I, because of the silliness. Well, look
Yeah.
at that. Where in the world did you find that, Jerry?
Oh, just open my magazine.
Oh, but it
Hawking
comes
radiation is a clear example of a clash between general relativity and quantum theory, but it is also a process that can be explained only through the application of, and I think it's of both of these things. The solution to the black hole information paradox could be the key to describe our universe under a unified framework.
Oh,
So that's coming up next week.
Okay. Well, if
that'd be great.
we can ever get a speaker book, that is one popular subject about astronomy is
Yes.
whatever color they are, holes.
Yeah.
Got to
Okay.
give them some color, don't we? What color can they be if it's not black? I don't understand.
Purple.
Dark gray.
Dark gray holes. All right, let's do it
You
again
can
next
actually
week.
derive the temperature of a black hole.
All right. Are we done?
Yes, we're done.
All right, then we're going to say goodbye in our special way and invite you to join us for number 268 of the Santa Barbara